Hello students, today we are going to start our new topic that is pair of straight lines. Now, what is a pair of straight lines? A pair of straight line is an expression which contains two straight lines. Suppose these are the two equations of straight lines. Okay, if I express these two lines 1 and 2 in the form of equation 3, then this equation or this expression is called equation of pair of straight lines. Okay. Now clearly the coordinate of each line 1 and 2 satisfy equation 3. Okay, you can put the value of x and y. So if it satisfy any of the line 1 and 2, then it will satisfy 3. It means both line 1 and 2 is contained in pair of straight line 3. Clear? Means it represents at a time it represents two straight lines, and hence we call it a pair of straight lines. Okay, expanding this equation, we got a equation of second degree. It is obvious. Now this is our first result. A homogeneous second degree equation always represents a pair of straight lines passing through origin. Okay, so homogeneous means all the terms have same power. Here x square, so x into y, that is 1 plus 1, that is 2, and that is y square. So all the term is of degree 2. So this equation is homogeneous for the 2. Now this equation represents a pair of straight line passing through origin. So best way to show that this equation represents a pair of straight line passing through origin is to find the individual equation of straight lines. Okay, for that we take this b common and we got this quadratic equation in y. Assuming x is constant in your mind, we can express this as y minus m1x and y minus m2x. So on simplifying and compare it with this equation, you can easily see that m1 plus m2 is minus 2h by b and m1 m2 is equal to a by b. Thus the homogeneous second degree equation represents two straight lines, y minus m1x equal to 0 and y minus m2x equal to 0, and clearly these two straight lines passes through origin. Clear? Now the lines are real and distinct. Now obviously these are m1 and m2 are roots of these equations. So m1 and m2 are real and distinct, then the lines are also real and distinct. If m1 and m2 are same, it means these lines are real and coincident. Basically this is just one line, or you can say one line upon another line. Now if m1 and m2 are complex conjugates, then lines are imaginary. Okay, so this is what pair of straight lines looks like. Okay, so another part is for the quadratic equation. This, if you consider this homogeneous second degree equation, then you can see that using the completing square method, we can write y is equal to minus h plus minus square root of h square minus ab by b into x. So you can express this using completing square method. Now here you can see that this line, this is an equation of line. This is same as writing y equal to mx. Okay, this portion is your m. Now you can easily see that this m is real if h square minus ab is greater or equal to 0, and imaginary if h square minus ab is less than 0. So when we are talking about real lines, in that case by default we consider h square minus ab is always greater than or equal to 0. Now come to angle between the pair of straight lines passing through origin. Suppose y equal to m1x and y equal to m2x are the individual equation of the pair of straight line, this one. Okay, so we know m1 plus m2 is equal to minus twice h by b and m1 m2 equal to a by b. So let theta be the angle between the pair of straight lines. So this is a pair of straight line and this is your theta. Okay, then we know the formula of finding angle between two straight lines, and that is tan theta is equal to m1 minus m2 divided by 1 plus m1 m2. Here, so from here I can write square root of m1 plus m2 whole square minus 4 m1 m2 divided by 1 plus m1 m2. Okay, now we have the value of m1 plus m2 and m1 m2. Putting these values, we can see this tan theta is equal to this quantity. So the angle between the pair of straight line is tan theta is equal to 2 square root of h square minus ab divided by a plus b. So from here we can see that if the lines are coincident, that is theta equal to 0, then h square minus ab is equal to 0. This is the condition of line being either parallel or coincident. If the lines are are at right angle, then denominator is 0, that is a plus b equal to 0. So if in this equation ax square plus twice hxy plus by square equal to 0, this a, suppose a is 2 and b is minus 2, then a plus of minus 2 is equal to 0. It means this line, the individual lines in this pair of straight line are perpendicular. So these two numbers are of opposite sign. If these two numbers a and b are of opposite sign and equal value is same but sign is opposite, then the lines in the pair of straight lines are always perpendicular. Okay, fine. Now come to bisector of angles between the pair of straight lines. Okay, let's see whether I made that diagram. Let me explain the diagram. L1 and L2 are two individual lines. Combining L1 L2 we have pair of straight lines. Now this line is the bisector. Okay, let me change the color. This line is the bisector. So this is the angle theta, this is the angle theta 2, and this is the angle theta 1. Theta 1 is made by L1 with x-axis, theta 2 is the angle made by L2 with x-axis, and bisector makes the angle theta. Clear? So this diagram is clear. Now again, this is also a bisector if you consider this L1 L2 and this is your L1. So this is also a bisector. So we have two bisectors. Okay, now and it is also clear that the angle between these two bisector is 90 degree. Okay, that is pi by 2. So if we know theta, then theta plus pi by 2 is the angle made by another bisector with the positive x-axis. Okay, let's come to the proof. Let theta 1 and theta 2 be the angles that the straight lines makes with the positive direction of x-axis. Then the two straight lines AO A dash and BO B dash given by the above equation are respectively y equal to x tan theta 1 and y equal to x tan theta 2. These are the equations of straight line L1 and L2. It is clear. Okay, because tan theta 1 is the slope of line 1 and tan theta 2 is the slope of line 2. So if you know the slope, then the equation of straight line passing through the origin is always y equal to mx. So we can easily write y equal to x tan theta 1 and y equal to x tan theta 2. From here, if this is the individual equation of lines, then and tan theta 1 and tan theta 2 are the slopes, then we know that m1 plus m2 is equal to minus twice h by b. So here tan theta 1 plus tan theta 2 is equal to minus twice h by b, and tan theta 1 into tan theta 2 is a by b. So this is something we know. Okay, let theta be the angle that either bisector makes with the positive direction of x-axis. Then theta is equal to half of theta 1 plus theta 2, or as I said, if you add 90 degree, it will give the angle of another bisector. So theta is equal to pi by 2 plus half theta 1 plus theta 2. So in both the cases, tan 2 theta is equal to tan theta 1 plus theta 2. Okay, this is clear. Or tan 2 theta can be written as 2 tan theta by 1 minus tan square theta, and here I can write tan theta 1 plus tan theta 2 by 1 minus tan theta 1 tan theta 2. Okay, putting these values, we get 2 tan theta by 1 minus tan square theta is equal to twice h by a minus b. Okay, now taking any point on the bisector, so let xy be any point on the bisector, then I can explain this to you using this diagram. Suppose here I have taken x comma y, this is your y and this is your x. Okay, then if this is the angle theta, okay, then this theta can be expressed as tan theta is equal to y by x. So for any point x comma y, I can express tan theta is equal to y by x. Okay, so in place of tan theta, I can write y by x. Okay, so 2y by x divided by 1 minus y square by x square is equal to twice h by a minus b. So on simplification, we get x square minus y square divided by a minus b is equal to x y by h. So this is an expression. We express the equation of bisector in this form, okay, which is the required equation of bisector. So this completes the theory of pair of straight lines. Up to this part, the students of FYUG taking IDC as mathematics, they need up to this portion of pair of straight lines. In the next video, we'll solve some problems, okay, so that you can understand what type of problems will come in the examination. Okay, thank you so much.